Okay, in this section, we'll cover some database topics, which include various ways of updating the scene. We'll dive a little bit more into segment operations, and particularly talking about querying information out of the database and searching the database, or the scene graph. There's a couple slides covering how we can associate information in the database, in the scene graph, with other data structures in your application. And then we'll move into an exercise involving finding and deleting geometry. So this is something we'd covered in a previous section. We'll get into a little bit more now. There are a variety of ways of updating the scene. So in review, the scene graph has been defined, or the graphics database, we can also call it. And every time we make some set of changes, to see the results of those changes on our display, or if we wanted to re-export a file or what have you, you need to tell the Hoops Visualize database to update. So if we're using the view hierarchy, as we mentioned before, which is listed up here, we have a canvas, a layout, and a view. Oops. A canvas is going to be associated with a native GUI application window, and then it can have a layout with multiple views. Most often it'll just be one view in this case. We'll get into that in a little bit later. But then you can update at a canvas level or a specific view level. It would only make sense to worry about updating a specific view if you had more than one view. Otherwise, you could always just keep updating the canvas in general. Okay. And another approach is to, if you're not using the view hierarchy, where let's say we'll just create an application window and then to have that be connected to a native GUI window handle, then that's simply taking that window key for that window key segment and calling the update method on it. Again, all of the sandboxes will, by default, construct that view hierarchy. So if you're going to be prototyping, starting to do testing and debugging and whatnot, starting with one of the sandboxes, you'll almost always just use canvas update. That's going to be the most common way of going forward. So when we get into updating the scene, there are actually two ways, independent of whether it's done on a canvas or view object or done on a window key object. There's two approaches of updating the scene. If you just call update, that is asynchronous, meaning your code is executing, you call update, and that function will return right away and continue. So that update could, for example, be happening in the background if it was going to take a very, very long time, and your code could continue executing. And Hoops Visualize will, because it is re-entrant and thread safe, if there's other operations happening later on, they could be put in a queue because the database might need to be locked. So for example, if we're in the middle of an update, called update in this asynchronous way, and we've just continued execution of the code, some of those other database operations might edit the database, but if a view is in progress, that's not going to be compatible. So we will lock the database, and those edit operations, for example, would be put in a pending queue. Some operations are safe to be called while an update is in process. For example, querying the database. If an update's in process, we can query the database. So the way to do a synchronous update is to say update with notifier, meaning Visualize will actually give back a notifier. You set up a notifier object here. Okay, so I set up an update notifier object. I get back a handle to a notifier. I call my window key, in this case, update with notifier. And then on that notifier, I will wait. So that is synchronous. So that's going to block and wait until the update is finished for code to continue. So why might you want to do that? Well, quite often. Anytime you need to know before you let the user continue interacting with the scene that you want to guarantee that the current scene matches the database. So one example would be the user is clicking and interacting and orbiting the scene, or doing a real-time highlight or something like this. You wouldn't want to have things, updates that might take a very, very long time, start lagging behind their current operations. They need to know that what they're interacting with is the actual current accurate state of the database. So most types of dynamic live interactions with the visual display will be update with notifier followed by update notifier wait. That's going to be the most common situation. There may be specific cases when it's okay to just do an asynchronous update. For example, a file export operation, and you don't want that to block the whole application. You want to say file, save as, let that go off in the background, and then continue. However, again, if you're doing a file save as, that is essentially going to be an update as well, because you're going to call update on that type of file export object, which we'll cover a little bit later. And some operations will still be allowed. You could continue interacting with the scene by rotating or orbiting a camera, because you might be in a different view. You could be querying in the scene. So it depends on what kinds of operations might still be permissible. There's also a concept of a regular versus a timed update. So a regular update refers to, by default, if you call update or update with notifier, Hoops Visualize will take as much time as it needs to traverse the scene graph and draw it to the active display or displays, whether it takes a second or it takes 2 minutes. A timed update is a way to tell Visualize to actually only have an allotted amount of time with which to work on that update. So if you gave it 1/10 of a second, it will update as much as it can. It'll draw as much of the scene as it can within that 1/10 of a second, and then return from that call. So you might say, well, why might I want to do this? Timed updates are internally used in our out-of-box presented fixed frame rate logic. So later on, we'll see that you can set a fixed frame rate on the canvas object. Say, I want 30 frames per second. And so anytime that you are doing any kinds of updates based on camera operations, selection, highlighting, editing, interacting with the scene, that canvas will always ensure 30 frames per second. What it's doing internally is every time it calls update, it's doing an update timed with a value of, to ensure 30 frames per second. So that's something that would typically only be used in our fixed frame rate logic, but it may be useful if you want to kind of have a specific allotted amount of time. And again, we'll cover that a little bit later, the section of a fixed frame rate. In this sample code here, we're giving it a max of 3/4 of a second to spend on rendering. Okay, so we're doing a window key update and 3/4 of a second. As you can see here, this is going to be an asynchronous update. This function is going to return immediately. Okay. This has been touched on a few times now. I'm going to dig into a little bit more. The different window types. So this has a big impact on how we're updating the scene. The most common usage is an application window. Okay. So in an application window, we actually will set up on the stack, we'll instantiate a struct application window key. And when we create that window, we're going to call the create application window method. And this will instruct Hoops Visualize to draw into an existing native GUI window. So that means if I'm using Microsoft Foundation classes or WPF, WinForms or Qt or WX widgets, or any other native GUI toolkit, you as a developer are building your native GUI application with all your icons and windows and list boxes. You create one of your windows for your view, you get a handle to that, and you pass it into Hoops Visualize in the create application window. So we are not going to create any GUI elements. This just tells Visualize where to draw the scene underneath that segment the segment tree underneath that segment, including any included segments or reference geometry or whatnot, into that window. So this is a very special segment, as I mentioned earlier, an application, a window key is a very special type of segment, a window keyed segment. So here we give an example. After we set this up, the create application window, as you can see, takes the window handle and also a driver type. There's a default 3D driver type. It's called default 3D. We'll choose internally whether to use for visual display on the screen OpenGL as the underlying 3D rendering interface or Direct 3D. But you can specify which one you like. So if we look at this method here, we can see the default is default 3D. Okay. And then we are showing that we include a segment. Okay, this model key, maybe another model has been built under a root segment, a whole model structure. Maybe a file has been previously loaded into that segment underneath model key, and then we're going to do, in this case, an asynchronous update. Okay, and then another type is the off-screen window. So very similar to the previous sample code, but in this case, you'll have an off-screen window key, which will be returned to you when you create an off-screen window. And as you can imagine, that's going to be basically a memory buffer. So some people will refer to it as just an image. You know, it's just a buffer of memory. So the most common way to set that up would be to set up an off-screen window options kit. And then when we actually create the off-screen window, we pass in that kit. That'll give us a little bit of configuration of some options. Okay. And the way you would access that later is you would have Hoops Visualize write that data into an image kit, and then you could query or show that information. And let me see if I can go down. Okay, so later on we've already we've set up our image kit here. We fill our image kit with the contents from our previously created image. So we have our off-screen window options control. We're going to show image, so that's going to actually read those pixels back. And then to actually show the data into some image data buffer in this case, we're going to get that image kit and show its information. Again, this image kit is an external object outside of the scene graph, outside of the database. And there's different ways to control the format for this image when I have Hoops Visualize rendered to this off-screen window. You can specify the formats. When we show this image back, it can be written back to you in various types of formats. So if we look at this image format, here's all the different formats that you can ask for that off-screen image buffer data to be presented back to you in. Most commonly, you probably want an RGBA. There might be alpha values in there, but maybe you want just grayscale. And what might be the most convenient, actually, I just realized now, is of course some of these defined image formats. So you can imagine if you wanted to just get a screenshot, this is one way to get screenshots. There are, however, a couple other mechanisms to get screenshots. You can actually call window key show snapshot, and you also get a set of options, again, to be able to convert that image data to different formats. Okay. And then later on, again, you could similarly then just actually directly access that data. So the way to get at that data is to get that image kit show data. Then you have a blob of, in this case, PNG, an actual PNG image data. You could then go ahead and write that out. Maybe you want to pipe it over somewhere, it depends. Okay. And there's actually a third way. In addition to this direct way of getting the off-screen window into an image kit or doing a show snapshot, you can also use the image file IO class. So this is actually going to basically let us save out, we could import or export, in this case, importing 2D images directly into the scene graph. You can imagine this might be useful because you're going to want to import images potentially to use them as the basis for a texture, to define a texture, which usually needs a source image. And then down here we have, for the image class, we have the export function being called. Save out to a specific file name, and then the image kit has all the image data. We'll get into these file IO concepts and different classes a little bit later. So this is just to show that, in case you were wondering, well, instead of just going to a memory buffer that I have to query the raw bytes, can I just save it out to an image on disk? And the answer is, of course, you can, yes, with the image file IO class. Finally, there's another window type. These are the window types used by these standalone samples. They're creating standalone windows. So you're maybe wondering, we just compiled these samples and I get this one window that's just this, taking up the whole screen. So internally, if you ask Hoops to create a standalone window, we will create a native GUI window. We'll create an MFC or WPF window or a Qt window. These standalone windows are only recommended to use for like quick prototyping, quick samples. If you don't want to deal with a sandbox and compile a sandbox, they're nice because any time you have code that's just creating a standalone window, it's 100% source code, platform independent code. It's what we call hoops. It's hoops only code. We internally will figure out if you take any one of those samples that's creating internally a standalone window, if you're running under Qt or you're running under OS X or iOS or Android or what have you, we will internally figure out what type of native window to create. So under Linux, we'll create we might actually, I think, even create an X11 window, for example. We're not going to require that Qt be used for these standalone windows. And it's very similar to the application or off-screen windows. You will call the create standalone window, and you get back a standalone window type of kit. There's a couple other tweaks where you can set the default of when this window is first created, what size it will be, and what control, aspect ratio control is enabled on this window, but not that critical. So again, and to wrap this up, all applications that are built in the CAD/CAM CAE world with Hoops Visualize are based on an application window. People, of course, you're going to create your own custom application. You're going to build your own native application windows and instruct Hoops Visualize to draw into them by passing the handle of that window into Visualize using the application window approach.